Hello, so today we are talking about confidence intervals. So in class, we had like an introduction day to confidence intervals, and this is building on some of that knowledge and going into more detail as to how we word things and how we calculate them. So this is section 8.1 in your textbook. Your homework comes from this section, and there's extra examples in that section if you want to go look at them. So we're going to focus on this one example today. It says a large company is concerned that many of its employees are in poor physical condition, which can result in decreased productivity. To determine how many steps each employee takes per day on average, the company provides a pedometer to 50 randomly selected employees. So that's my first kind of big piece of information, 50 randomly selected employees to use for one 24-hour period. After collecting the data, the company's statistician reports a 95% confidence interval of 4,547 steps to 8,473 steps. So this is my interval, and remember we've written that before as just 4, 5, 4, 7, comma, 8, 4, 7, 3. So we write confidence intervals like this, or it could be written out from blank to blank. So the first question says, interpret this confidence interval. Well, if I think about interpreting the confidence interval, we have a couple ways to do it. The first way that we talked about is 95% confidence means, and then we said that if we take many samples of the same size from the same population, meaning if I took many samples of 50 from this same large company population, so I kept taking different samples of 50, took 50 more, took another sample of 50 more, about 95% of those samples would contain the true average steps the company takes. So if I were to write that out, it would say this. So I typed it out because I know my handwriting gets a little funky on here. So if we take many samples of 50, so I included the context, employees, from the same large company, about 95% of the samples would result in an interval, so would result in one of these that contains the true average. So we don't know the true average. We're estimating it using an interval, and this would be one way of interpreting it. Another way that we talked about, just to review from class, says we are blank % confident that the interval from blank to blank captures the, and then this is where you include your context. So if I were to put context to this template, it would say we are 95% confident that the interval from 4,547 to 8,473 captures the true mean number of steps taken per day for employees at this company. So there's two ways of interpreting. Kind of choose your way and stick with it. So you can choose either way of interpreting you want and stick with that way. So key point number one, and what we're going to focus on today, is that confidence intervals follow the form, the point estimate, so the statistic from my sample, meaning my p-hat, or my x-bar, plus or minus the margin of error. And this margin of error is going to change for different problems, so it says the formula is going to change. Each interval that we make, and we're actually going to make 5 different types of intervals, each interval has a different formula for this, but it's always the statistic plus or minus the margin of error to give me my interval from blank to blank. So let's take a look at the same example and see if we can find the two parts of my formula, the point estimate and the margin of error. So it gives me the same interval. My interval goes from 4,547 to 8,473. Now, if I want to find the point estimate, that's the number in the middle of this interval. Remember, the point estimate is the center, and then I add and subtract the margin of error, so I need to find what was the x-bar that I subtracted the margin of error and added the margin of error to get 4547 to 8473. So what we're actually going to use is the midpoint formula from geometry. You thought you were done with geometry. You are not. We are going to use the midpoint formula to find this middle x bar. So 4547 plus 8473 divided by 2 gives me 6510. So the point estimate, or the x bar, from my sample was 6,510 steps per 24-hour period. So this would be the point estimate. Remember, the point estimate is the x bar or the p hat. This problem's talking about averages and numbers, not proportions. So x bar, or the point estimate, is 6,510. But then what's the margin of error? Remember, x bar's in the middle, and then I add something and subtract something to get to this 4,547 and 8,473. Well, in order to find it, I can just do the point estimate minus 4,547, and we get 1,963. You could also do it from the upper bound. You could do the 8,473 minus 6510, and you get 1963. So the margin of error, sometimes I abbreviate it MOE, is 1,963 steps. So the margin of error is what I add and subtract from the point estimator. It's this distance right here. And the margin of error depends on the problem and the level of confidence we want. If I want to be more confident, this margin of error has got to be bigger because it has to make a bigger range for the mean to truly fall in. If I'm okay being like a little bit confident, my margin of error is going to be pretty small and my interval is going to be small. So the margin of error depends on this confidence level. They're very closely related. The real definition, or kind of to get a true definition of the margin of error written down, is how far we expect the sample statistic, or x bar and p hat, to vary from the population parameter. Remember, the population parameter is the true mean or true proportion at most. So this is saying how far can I stretch my interval? How much kind of wiggle room can I give myself that I'll still contain the population parameter? In practicality, it's what we add and subtract from the point estimator to get our interval. So why do we want to find confidence intervals? What's the point of going through all these steps? Well, we talked about a big point in class, and that's the fact that we don't know mu or p. I don't know the population parameter, so I'm estimating it. Another reason is we can kind of make claims or reject claims based on our interval. So we're going to take a look at the same example, but we've added part D. So part D says, recent guidelines suggest that people aim for 10,000 steps per day. So this is the goal, and we want to know, is there convincing evidence that the employees are not meeting the guideline or not meeting this claim? And you have to explain it and give justification. So if we think about our interval, it goes from 4,547 to 8,473. And we're 95% confident that the true mean, or the true average number of steps employees take, goes from 4,547 to 8,473. So do we have evidence that says they're not meeting the 10,000 mark? Yeah, we do. Since my interval goes from 4,547 to 8,473, we have evidence, and we actually have kind of strong evidence, that the company is not meeting the 10,000 claim because 10,000 is not in my interval. If 10,000 were in this interval, I would not have evidence that they're not meeting the claim. But since 10,000 is not in the interval, we have strong evidence that the company is not meeting the 10,000 step aim because 10,000 is not in my interval. So since 10,000 is not in the 95% confidence interval, because I'm 95% that the true mean is in there, 10,000 is not in there, meaning their average is probably not 10,000. We have strong evidence that it's not 10,000. So key point number 3, if a value is within the interval, we do not have evidence to reject a claim, but if a value is not within the interval, we do have evidence to reject the claim at whatever confidence level the problem gives us. So this is key point number 3. This is huge when it comes to interpreting intervals, which is what we're going to focus on next class. So the last part of the example, if the company reduced the confidence level to 90%, how would the interval of steps change? Well, we talked about this in class, and just to get another example, if we lower our confidence, meaning if I'm okay being wrong 10% of the time instead of 5% of the time, then the interval is going to become smaller or more precise. So if we lower our confidence, the interval gets smaller, as opposed to if we raise our confidence, the interval gets bigger. So that was the last example. We use confidence intervals to estimate a population parameter because we don't know the population parameter, so we're estimating it. If we're given an interval, we can find the point estimate and the margin of error. So this is section 8.1, and that's a wrap.